What is going on, guys? Welcome back. In today's video, we're going to learn about SQLAlchemy or SQLAlchemy, which is an SQL Toolkit and Object Relational Mapper, a Python module that allows us to map Python classes and objects to database tables and entries. So let us get right into it.
It's not a game, it's a rich thing.
Alright, so SQLAlchemy is an object relational mapper, which basically means that it allows us to translate Python classes and Python objects to database tables and database entries. And when we work with these Python objects, for example, we create a new Python object, we delete it, we change it, whatever, the respective action will also be translated into a database action without us having to write any SQL code. So we don't need to do anything like create table, insert into, select from. Everything will be done automatically by SQLAlchemy, and we can focus on the Python objects, on the Python code. And in today's video, we're going to learn how to do that. We're going to use a simple example of a person class and a thing class, and a thing can be owned by one person. For the sake of simplicity, we're not going to have one thing being owned by multiple people, but we will have the possibility of one person owning multiple things. So this is going to be the simple example of today's video. And to start, we're going to install SQLAlchemy. By the way, for those of you who say it's called SQLAlchemy, or those of you who say it's not called SQLAlchemy, actually both ways of pronouncing SQL are fine. So you can say SQL, you can say SQL, both are accepted. I think the original name is actually SQL, but yeah. So pip install SQLAlchemy, and once you have that, we're going to start with a bunch of imports. So once this is done, we're going to say from SQLAlchemy import create engine. We're going to import also the foreign key relationship. We're going to say from SQLAlchemy, we're going to import, actually we can do that in the same line here, column. Now maybe I'm going to just put this down a little bit here so that I'm not blocking this with my camera. We're going to also import column, we're going to import string, we're going to import integer, and we're going to import character. So those are basically just data types for the columns. This is the column itself. This is the foreign key relationship of the database that we're going to define. And this basically creates the engine that we can connect to, because SQLAlchemy is compatible with a bunch of different database types. So we can use SQLite, we can use MySQL and all that. In today's video, we're going to use SQLite because that's just the most simple database we can create by just creating a file. Then we're also going to import from SQLAlchemy .extension or .ext declarative. We're going to import the declarative base. This is essentially the base class that we're going to extend, that we're going to inherit from for our person and thing class. And then we're going to say also from SQLAlchemy .orm, which is the object relational mapping, we're going to import the session maker. And the session maker will essentially make a session. Then we can start the session and we can do stuff in the database. So those are going to be the imports. And we're going to now say that the base class that we want to inherit from will be created by saying declarative base. We're going to call declarative base. This is going to return a class. And this class will then be the base for our first class, which is the person class. It will inherit from base. And we're going to now define a bunch of things here. First of all, we have to set a table name. So we need to say underscore underscore table name underscore underscore, and this will then be the table name inside of the database, inside of the SQLite database in this case. So we're going to say table name equals person, or actually we specify the plural usually. So we're going to say people will be the table name. Now, some might argue that persons, even though that's not English, might be a good name because, yeah, it will be easier to find automatically, but we're going to use people here. And then we're going to specify the columns, and the columns are essentially the attributes. So we're going to say, first of all, the person should have a unique identifier, the primary key, so to say, and this will be the social security number of that person. This will be a column, and it will be, it will have the name SN also in the database. It will be an integer for the sake of simplicity here, and it's going to be the primary key, which is why we set primary key equal to true. Then we're going to say first name will be column, first name will be a string. Then we're going to copy this. We're going to say the last name, will be a column called last name. So essentially the pattern is quite simple. You provide the attribute name, the variable name inside of Python. Then you say it's a column, then you specify the database name, then you specify the database data type, and you can also set some optional parameters like, is this nullable, is this a primary key, is this unique, and so on. Then we're going to say gender will be equal to column gender, and this will be a character. And then we're going to say age will also be a column age, and this will be an integer. So this is our basic person class. Now we're going to write a very simple constructor, so a very simple init method, where we just say that we can pass all these things right away. So first, last, gender, age. Now professional, if you're writing professional code, you should probably also use first name and last name here, but I want to do it like that so that I have to write less. So SSN is SSN self.ssn will be equal to SSN. Self.first name will be equal to first. Self.last name will be equal to last. Self.gender will be equal to gender. And self.age will be equal to age. And then last but not least, we're going to write a simple wrapper function, basically just a function that allows us to specify how we want to print a person. So when we print a person object, what do we see? I'm going to return a basic f string. We're going to start here with a primary key, the self.ssn, the social security number, followed by self.first name, followed by self.last name. And then we're going to have self.gender, comma, self.age. That will be the basic string. So let me zoom out a little bit. That's our person class. And now we're going to add another class, or maybe let's do it first only with a person class, and then we're going to add another class. But let's start just with a person class and see what the process afterwards is. And then we're going to add the thing class, where a person can own a thing, and a thing can be owned by one person, but a person can own multiple things. We're going to model that here in a second as well. But let's just move on here before we do anything else, just with the basic interaction with the database. So what we need to do next, once we have the classes, or in this case the one class, is we need to create an engine. So we say engine equals create engine. And now we need to specify the database. So if you have MySQL, there is a way to connect to MySQL. And for all the different database types, you have different ways to connect to them. In this case, we're going to just say SQLite :///. And now you can choose to use an in-memory database, so in the RAM, which will be a new database every time you run the script. Or you can choose a file database, which is what I'm going to do. So I'm going to call this mydb.db. And we're going to say echo equals true. And this then connects to a SQLite database. This will create a file and work with the file. So what we do next is we say base.metadata.createAll bind equals engine. And what this does essentially is it takes all the classes, in this case just one, that extend from base and creates them in the database. So it connects to the engine and creates all these tables. So the person table will be created after running this line of code. And then what we do is we say session with a capital S, this is just a convention, equals session maker bind equals engine. So we create a session maker, and the actual session will be a lowercase s session, which will be just a constructor. So this is essentially the class, and this is then the instance. That's the basic idea. We create a session, and with that session, we can now do all sorts of things. So for example, we can say the person is equal to a person object, and we're going to say now that this person will have just some social security number. It will be Mike Smith. He will be 35 years old. Actually, we need to pass the gender first. He will be male, and he will be 35 years old. And with that person, we can now just say session.add that person, and this person will end up in a database. So I can just say session.add person, and without writing a single line of SQL code, this person will be created in the database. And the table will also be created by this line, as I mentioned, and this line will then create the person. Now to actually create the person in the actual database, we also need to commit. So we need to say session.commit. This will then apply the changes to the database. This will then flush it, so to say. So if you have a file stream, usually you have to close it or flush it. In this case, we need to commit whatever we want to do. And we can do that with a bunch of different persons. So we can copy this now, or people, sorry, not persons. We're going to say P1, P2, P3, and we can create a bunch of people here with different social security numbers, since this is a unique value. And we're going to have Anna Blue. She will obviously be a female. And let's say she's 40. Then we're going to say we have Bob. Bob will be also blue, so they're maybe related, maybe not. He will be, let's say 35. This was the value before, but doesn't matter. And then we're going to say that we also have Angela, I don't know, Cold or something. And this will also be female, and we're going to say 22 years old. And then we can just say session.add P1, P2, P3, and then session.commit. And this will commit these people to the database. I can run this now. You can see actually what happened here. So create table people. This is the generated SQL code. And here we also have insert into people, blah, blah, blah. So you can see how all of the actions here are translated to SQL code. We can double click the database in PyCharm. We can open it. And we can see here in the tables, in the people table here, that we have the entries in the database. So this was done without writing any SQL code. Now we can also do the same thing with queries. So we cannot only create objects and insert objects, we can also query objects in a very simple way by just saying people, which will be our result set. So let's call this not people, but results, will be equal to session.query. And we can then specify what table we want to query, in this case, the person class, so the person table. And we can just get all the people, for example. So this would be select everything from person or select everything from people. And this will be the result set. So I can just print this here. And in this case, we will get an exception because we already have a database. But when I run this here, you can see this is the result set. We have Mike Smith, we have Anna Blue, Bob Blue, Angela Code. So we get the actual Python objects as a result here. So when we query the data from the database, so actually I can show you that this is really part of the database. I can uncomment, or I can comment all of this. So we don't create these objects again. We already have the database, and I will still get the values here. I will still get the objects, and I get as a result here a list of Python objects. So I get actual Python objects from the database. This is quite impressive, and we can also use that to filter. So I can not only say all, I can also say, okay, from that result set, filter, because I only want to have the person or the people that have a first name, or actually, let's do something else. Let's do the last name is equal to blue. So in this case, I should get 2 people here. What's the problem here? I didn't get much. Do I have any results here? Or did I do something wrong? This is a query. Maybe I do have to iterate over it. So let's do for r in results. Print r. I'm not sure if that's the problem. There you go. We get Anna Blue, Bob Blue. Okay, this worked. So we can filter like that. We can also do some more advanced filtering. But first of all, let me show you. We can also use numbers. So we can say person age has to be above 25. So this should exclude Angela, as you can see. And then we can also do some more advanced stuff, like, for example, the first name has to be like. So first name like, and then I can use the function where I say, okay, it has to, what names do we have? AN, for example. It has to be like %AN%. This will find Angela and Anna. There you go, as you can see here in the result. And we can also do stuff like checking if the name is in the list. So I can say, okay, the first name has to be one of the following by saying in_, and specifying then a list of, let's say, Anna and Mike. And this will then give me Anna and Mike. So this is how we can do queries. Let's now move on and implement the thing class as well. This will add a foreign key relationship, and you can see that this will, you will see that this will also be modeled very, very easily without us having to do anything. So I can just say class thing, which will also be extending from the base class. We're going to say table name equals things, and we're going to say that a thing can have an ID. Let's call it TID for thing ID, because ID is, as far as I know, a Python function. So let's go with TID is going to be equal to column integer. Actually, let's call it TID integer primary key true. Then we're going to say the description of the thing will be description string, and then we're going to say the owner will be a column, it will be an integer, and it will be a foreign key to people.ssn. So this string will refer to the social security number of the person class, so of the people table. So people.ssn will be the foreign key, and this will refer to the owner. Now, basically, all we need to do now is we need to also implement a simple init method. So we're going to say that we have the TID, the description, the owner. And again, what we're going to do here is we're going to say self.tid is TID, self.description is description, self.owner is owner. And then we're going to add a simple representation function here. We're going to just return f-string, and we're going to say that this will be self.tid. And we're going to provide self.description and owned by self.owner. That's the basic idea. And now let me see if we need to make any changes. I don't think so, to be honest. I think that everything we did up until now should also work with that change. So I should be able to delete the database, uncomment all that, and nothing should actually change other than that we have a new table. So if what did I do now? If I open up the database, I should be able to see that we now have two tables. Or don't we have two tables? Not sure if we have two tables. Okay, so let's see what happens when I just create a new thing. So what we're going to do now is we're going to say, instead of querying, I'm going to say t1 equals thing with the ID 1. It will be a car, I don't know, and the owner will be p1 ssn. And then I'm going to say session.add t1 session.commit. And let's see if that works. No, we have a problem. What's the problem? Unique constraint failed. Oh, I think this is because we already have a table, because we already have a database. So let's zoom in again and run this again. Now, as we can see here, create table things was actually performed. So this should actually work. Or do I have a display problem here? Maybe I have a display problem. I don't know. Maybe the interface doesn't work. So let's go select everything from things. And let's see if that is something that produces an output. There you go. We have a thing owned by this person here. So we actually do have the changes in the database. Maybe I'm just too incompetent to use the graphical user interface of PyCharm. But we can now go ahead and create a bunch of things. So T3, 4, 5. I can say we have a laptop. We have, I don't know, PS4, or actually 5 in this case. Then I might have some tool, and then I might have a book, and those have different IDs. I'm going to say this is also owned by person 1. This will be owned by person 2. This will be owned by person 4. We don't have a person 4, so let's do it like that. And then I can just add all these things. And after that, we should be able to also make some query that is a little bit more complicated, because now what we can do is we can say, okay, give me all the things that are owned by person 1. And how do I do that? I do that by saying results is equal to session query thing and person are the two tables that we're going to target, and we're going to say that the filter will be the following. We're going to say that the thing owner, the owner of the thing, has to be equal to the social security number, so the primary key of the person, and we want to have an additional filter. This person that owns this thing has to have a first name being equal to Anna, for example. And then I want to get all the entries. So this is the full line. And then we're going to say for r in results print r. And again, I think we need to delete the database, obviously. What's the problem now? I cannot delete the database. Why is that? Okay, let's just use a different name. Where is the engine declaration? Let's use mydb2, and then it should work. There you go. And you can see car owned by whatever and laptop owned by whatever. So you can see that we didn't write a single line of SQL code, but we modeled a foreign key relationship. We had two tables. We had a person that is able to own multiple items or things, and a thing can be owned by only one person. And we are able to create new people and new things, and we can also query for the things that are owned by a person. And we can filter, and we can do all these things without engaging in any way with SQL. So that's it for today's video. I hope you enjoyed it and I hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video and